Hello and good morning. Welcome to online classes. Today we are going to discuss chapter number 5, heat. In this chapter we will be discussing transfer of heat, conduction of heat, good and bad conductors of heat, uses of good bad conductors of heat, convection, convection current in nature, and practical applications of convection current. So let us begin with the transfer of heat. Due to the differences in the temperatures between the two bodies in contact, heat flows from a hot body to a cold body. That is, from a higher temperature to a lower temperature. If a body is brought in contact with a cold body, the temperature of the hot body falls and the temperature of the cold body rises. It is said that some quantity of heat has passed from the hot body to the cold body. The flow of heat stops when the temperature of both bodies becomes equal. There are three processes by which heat is transferred from one body to another. These are conduction, convection, and radiation. So today we are going to discuss conduction and convection. Conduction of heat. The process of conduction may be considered as the passing of a book from one child to another in a class. In solids, the molecules are very closely packed and they cannot move around freely. They can, however, move or vibrate about their mean position only. When one end of a metal rod is heated, the molecules at the end start vibrating at a faster rate. These rapidly vibrating particles collide with their neighboring molecules and transfer a part of heat energy to them. In this way, neighboring molecules also start vibrating. Thus, heat gets transferred from the hot end to the cold end, although each individual particle remains in its original location. Conduction of heat from one object to another takes place only under the following conditions. The two objects should be in direct contact with each other. The two objects should be at different temperature. Therefore, we can say that conduction is a mode of transfer heat from a region of lower temperature within a body, or when two bodies are in direct contact. It takes place by collision between the neighboring atoms and molecules. Good and bad conductors of heat. Materials which allow heat to be conducted through them easily are known as good conductors of heat. For example, metals such as iron, copper, silver, and aluminium are good conductors of heat. This is because the particles in them are in close contact. Materials which do not allow heat to flow through them are called non-conductors or insulators of heat. For example, wood, paper, glass, asbestos, and bakelite are non-conductors of heat. Air and water are also insulators. Most liquids and gases are poor conductors of heat, as the particles are further apart in them. Therefore, there is a lesser chance of particles colliding and passing on the heat energy. Usually, the materials that trap air inside them are bad conductors, for example, glass, wood, or wool. Uses of good and bad conductors of heat. Metals and their alloys are used in making utensils as they are good conductors of heat. Insulators are used for making handles of cooking utensils so that hot utensils can be lifted safely. Non-conductors like bricks and mud are used for building houses as they do not allow heat from the outside to enter the house during the summer. In winters, they do not let the heat from inside to go out, thus keeping the house warm. Woolen clothes do not allow our body heat to escape to the surroundings during the winter due to trapped air between their pores. Air is a non-conductor of heat, hence it does not allow the body heat to escape. Glass, wool and foam are used in ice boxes and refrigerators to prevent outside heat from entering the refrigerator. Oil tankers carry inflammable substances such as petrol and diesel during summers. The tankers are made from non-conducting material to minimize the loss of heat due to evaporation and prevent the occurrence of fire due to excessive heating of substances. Now let us see what is convection. Convection is a mode of heat transfer in which heat energy is transferred from one part to another by the actual movement of the molecules of the medium. Convection is possible in liquids and gases only, where the molecules are more loosely packed than solids and are free to move. The movement of water from the hotter end to the cooler region follows a specific pattern. Water near the bottom gets heated first, warm water being lighter than the surrounding cold water rises up. Colder water from the surrounding moves down, gets heated up and rises again. This process continues till the entire water attains a uniform temperature. This movement of water during heating is called convection current. Convection currents in nature. People living in coastal area experience an interesting weather phenomenon. During daytime, wind blows from the sea to the land, and at night, wind blows from land to the sea. During the day, sun shines equally on land and sea. The land gets heated up more quickly than sea water because land is a better conductor of heat. Air above the land gets heated up and rises up. As a result, the pressure of air on the land decreases in comparison to the sea water. Thus, air from the sea blows towards the land and causes a sea breeze. Since land is better conductor of heat, it cools faster than sea water during the night. Therefore, the air above the sea rises up as it is still warm. The cold air that is heavier starts blowing from the land towards the sea to take the place of warm air, giving rise to land breeze. Land and sea breeze are the phenomena which take place due to convection. Heat is transferred due to the actual movement of hot air molecules. Now let us see the practical applications of convection current. Ventilation in a room. Being lighter, warm air rises up and leaves the room through ventilators provided near the ceiling. As the air pressure decreases, fresh air enters the room through doors and windows. Thus, the convection current helps in circulating fresh air in the room. Room heater kept on the floor. Air heated up by a room heater moves up and the cooler air from the top moves down and gets heated to rise again. Thus, convection current keeps the room warm. Air conditioners are fitted at a higher level on the wall of the room. The cool air from the air conditioner, being heavier, moves, whereas the hot air at the lower level moves upward and gets cooled and moves down again. Thus, convection current keeps the room cooler.